So the next bit we want to talk about is sensor size. That's going to get you into different types of cameras. It's going to give you different types of effects and different types of resolutions and sensitivities and stuff based off of those sizes. And so like the smallest ones that we have right now that you're familiar with are going to be ones that are basically inside of your cell phones. These are incredibly small sensors. They're like millimeters, like 3 by 4 millimeters, so not very big at all. And depending on the type of phone that you have, will kind of give you a different sensor. So like iPhones and Androids and OnePluses and stuff, they all have slightly different sensors in there, and so they're based off of those. Those are always really small. Their pixel sizes are like incredibly small. You're talking about like half micron to 1 micron pixels. And when I mean a micron, that's 10 to the negative 6 meters. So it's actually really, really small. When you get up into other ones, like these ones, you're getting up into slightly larger ones. So these are like 6 by 5, maybe 6 by 7 or something like that sensor size. So they're pretty small still. You can get even farther up and go up from there. Like in a lot of astro cameras, like this little tracking astro camera has a pretty small sensor in there. You can kind of get an idea on there. Let me fix that. You can see how big it is just compared to there. So it's like basically smaller than a fingernail. So that's kind of standard for those. Just to give you an idea. And once you get up into slightly larger ones, you get a little bit larger sensors. And so you can see that one right there. It's just a hair bigger than that one, so you can kind of see that. But even that little bit of size that you see on those gives you kind of a huge difference in the amount of sky that you'll see if you're using this on a telescope. But even when it comes to regular cameras, the difference in sensor size is actually a pretty big difference. Causes a lot of different things to happen. So if we go into like APS size, and so there's actually a couple different styles of these APS sensors, or not styles but sizes. So there's the APS-C, which is inside of the Canon, and so you can see that one right here. This is the same size that they have on most of their cameras. They vary by like half a millimeter or something depending on which one you actually get. Some companies like Nikon and Lumix and all these other ones use slightly larger ones or slightly smaller ones. It kind of varies a little bit depending on the manufacturer, but it kind of gives you an idea of the difference in size between those and those. So it gives you about twice the size of the camera sensor on there between these two here. So you can see it a little bit better on those. But there's a big difference in those also. Now once you get up into a full frame size, I actually don't have a version of one of those that I can show you without having to rip something apart. But the APS sensor is the 27 by 18 or so, give or take, a millimeter or half a millimeter here or there. And then when you get into full frame, you're talking about 36 by 23, so it's a fair amount larger. And with those bigger sensors, you actually can have the same pixel density, so that means basically how many pixels you can have per square millimeter in there. So you can have the same pixel density but larger pixels on a full frame, meaning you have a higher sensitivity for light off of those bigger pixels. And we'll explain what all that big idea means with the sensor size or pixel size and stuff like that. And then when you get into medium format, you're talking about like 53, 54 millimeters by 40 millimeters. So even on the short end of those, it's still bigger than the long end of a full frame sensor. So it gives you an idea of how much larger they are. And that means, you know, you can have even bigger pixels, or you can have even more pixels in that entire area and maybe keep the pixel size the same. The bigger the image actually is on your sensor, the larger print that you can actually make. And so if you try making like a 20 by 30 print of an image based off of like one of the little iPhone cameras or something like that, you're going to blow an image up that is, you know, basically like this big into 20 by 30, and that just doesn't work. You actually get a ton of noise and stuff in there. So if you go from something that's about like this big into something like that big, the increase in size isn't quite as much, and so your images come out a lot nicer looking, a lot smoother, less pixelization, less noise, and everything else like that. So that's the main reason why a lot of people go into medium format if they can afford it, when they're doing portraiture and all these other things like that, and pictures of, you know, buildings and stuff like that that need really big really big prints and things of them, so you can retain the resolution that you're looking for. So there's a lot of other smaller lens or sensors out there that vary in size in between all of those, but there's like so many, it's kind of worthless to go through them. But at least you have an idea of, you know, the size difference as you're looking at kind of consumer-based cameras that you would likely get into when using or when you're pursuing astrophotography. Some negative aspects of having larger sensors, one of them is going to be that your image size actually increases. So your file size increases, which means instead of like an APS sensor that is like 20 megapixels, has about 22 megabytes per file, you go up into a full frame that has like 50 megapixels. Depending on how many bits that information has inside of it, you know, a 50 megapixel camera can have like 60 or 70 or even 100 megabyte files. And so that means you have to actually increase the amount of storage you have and increase the amount of processing power you have just to actually use those kind of things. So that's something that you have to take into account, is do you have a computer that's powerful enough for that, or do you want to spend extra money for a better computer in order to handle all these extra file sizes and stuff. The other thing is bigger files bigger files in the camera due to the bigger sensor size means that you can't really take as many photos. Like if you're looking for a burst mode for taking pictures of birds and stuff like that, if you're trying to get a bunch of photos in succession, if you have a high megapixel camera, it's going to take a lot more time to upload those to your storage card. And so if the company doesn't take that into account and adds a larger buffer to, you know, kind of retain some of that information as it's uploading into the card, then you're going to be limited to anywhere between like 5 to 15 or maybe even 20 images before those images stop, and the camera won't let you take any more images until that buffer has cleared. Or it'll take it down to like one image every half second, or one image every second, while it goes through all of that buffer loading and everything, or offloading. So that's something you want to think about with those. And then some cameras are more compatible with different lenses. Like if you look at the mirrorless cameras and the DSLRs, they're pretty interchangeable, which means you have like a few hundred types of lenses that you can switch between them. Whereas like the little rangefinders and fixed lens cameras, you basically only have that one camera lens that you can use, and you can't, you know, switch them out for faster lens or longer focal length lens or anything else like that. And so there are some downfalls with choosing those. And then mirrorless and APS size cameras have cheaper lenses overall because they don't need to make them quite as large. And so if you don't have to make the lens quite as large because you're not creating an image plane or an image circle for a much larger sensor, then you can use less glass and it costs less to actually make the lens overall. So that's one aspect for, you know, that kind of makes photography a little bit cheaper, is by having those smaller lenses for the APS and mirrorless cameras that have APS sensors in them. When you get up into like medium format cameras, the lenses actually get quite a bit more expensive because they have to have that larger image circle And so in order to get the right amount of light over that whole thing, you have to have a much larger lens, which means it's a lot more money for those. So you're looking at a very high investment in something like that if that's the direction you're going to go. And I personally haven't really seen any images of the night sky taken with large format cameras. Not sure why that is. Maybe it's just not part of that niche yet. So, but it'd be cool to see something like that, just to see how it works out. Not all of the cameras that you're going to be looking at is going to be fully compatible with astronomy and telescopes. So, like if you look at the image size on some of these smaller cameras, they're going to be like this big, those sensor sizes, and you're going to have like an image you're going to be able to see a certain amount of sky based off of how big that image is, because you're going to be looking at just a small aspect of the entire image circle that's coming through a telescope. And so if you get an image sensor that's this big and your image circle on your telescope's going to come out like this big, you're only sampling a small portion of that, which means the area of sky that you're looking at is going to be drastically reduced. And so that's something to think about. That's why these smaller astro cameras like this are ideal for things like tracking, because you only need to look at a few stars at a time. But it's not going to be very good for anything outside of like looking at pinpoint objects, maybe like some planetary stuff. Like this ASI 183 mm, this one is pretty good for doing planetary stuff. It's a decent sized sensor, so it's good for smaller telescopes that kind of compress all of that sky down into a smaller area. And it has a pretty decent pixel density, so it's going to give you a decent resolution off of that. So it's good for those kind of things. But when you get into the bigger telescopes, you actually need to jump up into larger chip sizes, because the image circle coming off of telescopes is going to be a lot larger. So it gives you a few options there, a few ideas of where to go and just how it would work based off of your image sensor size when you're getting into astrophotography. And when it comes to other stuff, it's not too bad. So a lot of times in photography, you're going to hear things called crop factor, and basically that is the difference between those lens or those sensor sizes. And so if you're comparing like a 35 millimeter sensor size and an APS sensor size, this APS sensor size is going to be a lot smaller. So when the light is coming through your actual telescope, or your lens in this case, if you use the same lens on both of those cameras, you're basically going to be cropping out the light that's coming from that lens. So that lens is going to produce an image circle, let's say of that big. That's kind of ideal for a image sensor of 35 millimeters, but if you use an APS sensor, you're going to be losing light around the edge of that, and so you're also going to be losing basically the field of view that you want on there. So a lot of people like to look at this and be like, okay, it has a 1.6 or a 1.5 crop factor, which means if you're trying to take a picture of something and you're basing it off of the millimeters of the focal length of your lens, then you have to basically multiply the focal length of that lens by 1.6, and that gives you the relative size of the image that you're going to be getting. And so you basically are zooming in by 1.6 times, but that's not really true, because there's not really any optical zooming going on. The only zooming that you're going to be doing later is zooming in the actual image itself to match the same size as the 35 millimeter image would be. So you're taking the APS sensor size and just kind of upscaling it to match that, but you're doing that in your computer. So there's not any real magnification going on. So let's say you want to do like an 8 by 11 print, and you take an image of something with your full frame camera and then your APS camera at the same focal length, you're going to get a much wider field of view with the 35 millimeter, and then when you put it onto an 8x11 print, it's going to give you, that whole thing. But when you try to do that with your APS sensor, you're going to have less field of view, but you're still going to try to blow it up to that 8x11 so it actually appears like it's more magnified, because you've lost some of the field of view but also upscaled that to match the 8x11 format. I hope that makes sense. It's a little bit weird, but that's actually the more truthful way of saying that. And so there's not really any actual optical magnification going on there. So you want to be kind of looking at that. And that's the same thing when you're looking at some of these images that are even smaller. You can blow them up, but if you're going from something like this big into a 35mm and printing it on an 8x11, depending on your pixel density of those really small sensors, you actually might just start getting really pixelated by the time you get that size. And so unless you have really, really tiny pixels, and a lot of them, when you blow it up to that 8x11 that matches the 35mm format, then you're going to be super over pixelated and it's going to look really bad. So that's something you want to take into account when you're thinking about those kind of things. So it's not really multiplying anything. So if you threw your 600mm lens onto your APS camera, that 600mm lens is actually something more like a 960mm. If you do the kind of upscaling that I was talking about, like kind of bringing that up into the same image size after printing. So it's not really zooming into 960mm. If you were to zoom in with a 960mm focal length lens on your full frame camera, that would actually provide better detail for you than using the crop factor idea with an APS sensor with a 600mm, because instead of upscaling that smaller image sensor size, you're full scaling a much more zoomed in image, optically zoomed in image, and so you're going to have that same portion of sky or that same portion of view, or that same field of view over the entire 35mm format sensor. And so it's actually a little bit better that way, unless you get something that has a lot of pixels and you can upscale that to the point where it's not losing or degrading any of the image quality, and kind of it will maybe match. It probably won't ever match the quality of a 960mm lens on a full frame, but it'll kind of match it. So there's like this kind of play of numbers and stuff that you have to take into account when you're thinking of this stuff. So it's kind of a cheat saying you're getting a 960mm lens by using it on a APS sensor body, because you don't have the same resolution, you don't have the field of view over the certain number of pixels and stuff, and it's not an actual true zoom. So you got to take that into account, and that's something you need to think about when you're doing astrophotography also, because just putting a smaller sensor onto the same telescope and blowing it up doesn't mean you're actually magnifying it anymore. It just means you're cropping out all of the wasted space and post-magnifying the image or the area of interest. So like if you're doing something like Jupiter and you have a 35mm lens or camera, Jupiter is going to be this little tiny dot on that 35mm, so you're wasting all of that extra stuff. But if you get one of these astro cameras that have a smaller chip, then you throw away all of that excess stuff. Don't worry about it. You increase your download times. You increase your frame rate if you're doing a video of them, and it's just a little bit better that way, but you're not necessarily zooming in anymore. You're just blowing it up a little bit more. That's all. So something to think about. Hopefully that makes all that makes sense.